Here in this case, if I used to do this question with the help of the conventional method, then I will be doing like this. This is the method which I have to use it. Limit x tends to 3 and I have to factorize this upper part. I have to factorize this part, and on factorizing, you know, with the help of the middle term split method, you can get it up to this. I am doing it. This is x square minus x minus 3x plus 3, and in the denominator I will be having x square plus x minus 3x and minus 3. Okay, you can easily do the middle term split method, and after doing all these things, what you will be having is limit x tends to 3, and in the numerator we will take x the common in the first two parts. I will be having x minus 1, and here if I take 3 common minus 3, here it will be x minus 3. In the denominator you will be having x plus 1 minus 3, x plus 1. Okay, now if I do it further, you will be having limit x tends to 3, and here this is x minus 3 in the numerator and x minus 1 in the numerator, as well as x minus 1 and this is minus 3, x minus 3 and x plus 1 in the denominator. This x minus 3 will cancel out one another, and now on applying the limits, on applying the limits, I will be having 3 minus 1 and 3 plus 1, which is equals to 2 over 4, which is equals to 1 over 2. I will be having 1 over 2 as the required answer without using the formula of L-Hospital rule, but it is going too much lengthy. But now when we come here in this form, I see that the part of the denominator is 0, and therefore it can't be done. Okay, now what I have to do is I have to apply the L-Hospital rule. In the numerator, it may be constant or 0, it won't matter much, but the main thing is we should not have the 0 in the denominator when we apply the limits. Now, what is L-Hospital rule and how we will do it? Okay, for this I have to do some rubbing here so that these things get removed from the board. Now see here, what L-Hospital rule says that you have to differentiate the numerator and the denominator individually. Okay, there is nothing linked between the numerator or the denominator. Here what I will have to do is limit this is x tends to 3, and if I differentiate x square here, it will give me 2x. If I differentiate minus 4x, it will give me minus 4, and plus 3 is 0. This is no use to write it. In the denominator, if I differentiate it, it will give me 2x minus 2 plus 0 or minus 0. Okay, now if I again try to use it, if I try to apply the limit, on applying limit, I saw if I put 3 in the denominator, this is 2y, 3 minus 2, it is giving me 6 minus 2 is 4, 4 is not equals to 0. 4 is not equals to 0. Then it means that I can easily apply the limits. There is no need to further do the L-Hospital rules or further differentiate the remaining function. Now it is of no use. Now here simply I have to apply the limits. On applying the limits, I will be having twice 3 minus 4 over twice 3 minus 2. Here in the numerator it is 6 minus 4, and 6 minus 2, here this is 2 and this is 4, 1 over 2. So what it means here in this particular question is, this is a very easy question, and in this question if you go with the ordinary method, then you have to first middle term the split method, and afterward you have to apply the limits. But here in this case, if you use the L-Hospital rule, in this particular case you don't have to go with any of the middle term, any of the things, you just have to simply differentiate the numerator and denominator individually. Okay, fine, just do another question. Let's do some more questions. We are having a question here. Here in this question, if you are going with the ordinary method, what you have to do is you have to just apply the formula for AQ minus BQ. Here if you apply the formula for AQ minus BQ, which is something like this, A minus B, and in the another bracket you are having A square plus B square plus AB, and in the denominator you are having A square minus B square, which will give you A minus B and A plus B. Okay, and now what you have to do is you have to apply this in this question. You will be having x minus 2 and x square plus 2 square, which is 4 plus 2x. Okay, because 8 will be becoming like 2 cube, we can write 4 as 2 square. Okay, now here in the denominator of x square minus 4, we can write it as x minus 2 and x plus 2, and the limit is tending towards 2. These both topics are cancelled out. Now we can apply here the rule here on applying the limits, because now denominator is not equals to 0. On applying the limit, I will be having like here, this is 2 4 plus 4 plus 4 over 2 plus 2. You will be having 4 3 12 and 2 2 4. You will be having 3 as the limit. Okay, but if you want to do it with the L'Hospital rule, this is L'Hospital rule. In the L'Hospital rule, you saw that if you put 2 in the denominator, it will be equals to 0. It means that you can easily apply here the L'Hospital rules. While applying the L'Hospital rule, what you will be having is, you have to write it like limit x tends to 2. Now here if you apply the L'Hospital rule, you will be having 3x square. 3x square, why? Because you have to differentiate x cube, and on differentiating x cube, you will be having 3x square minus 8. 8 is a constant number and it will give you 0. In the denominator, you will be having 2x, just like 2x. Okay, now this x will cancel out this x. You will be left with 3x over 2. Now here simply you have to apply on applying limit, and here the limit is 2. Here you have to write it as 3 times 2 over 2. This 2 will cancel out 2 and you will be left with 3. There is no need to remember, to recall, or to see into the books where is the formula for AQ minus BQ. Although it will be given in your examination that this formula can be used, but the main thing is that there is no need to use the formula. Okay, this is the beauty of L'Hospital rule. Let's go into some another questions. Just wait. With another question. In this question, you are given that limit x tends to root 2 x square minus 2 over x square plus root 2 x minus 4. This is the required question. Now here I am not explaining anything. I am not doing the formula a square minus b square. Either I am not using the Middleton split method. I am not doing another thing. I am directly and immediately applying the L'Hospital's rule. Here, what the L'Hospital rule states here. Here, simply this is limit x tends to under root 2, and if you differentiate the x square minus 2, it will give you 2x. 2x minus 0, it is 2x, and in the denominator part you are having 2x plus under root 2. Now here, what you will be having when you apply the limit in the denominator. When I apply the limit under root 2 in the denominator is 2x plus root 2. If I apply the limit as under root 2, it will give me twice root 2 plus root 2. It will give me 3 root 2, which is not equals to 0. What it means that when the denominator is not equals to 0, I can simply and genuinely apply the limits. On applying the limits here, I will be having 2 times root 2 over 2 times root 2, and this is root 2, this will give you 3 root 2, and this will get cancelled out. You will be left with 2 by 3. 2 by 3 is the limit of question number 3. Okay, next. Okay, let's do the next question. In the next question, I am having x square minus 9. X square minus 16, sorry. This is x square minus 16 over under root x square plus 9 minus 5. And here, if I try to apply the limit here as 4, I will be having 4 square plus 9 minus 5 in the denominator, and it will give me 16 plus 9 is 25. Root 25 means it is equal to 5 minus 5 is 0. It means that if I apply 4 as a limit in the denominator, I will be getting this as a 0. What it means that if it is like this, you have to solve the function And now here what we can do is we can simply apply the L'Hospital rule. In this case, what I have to do is I have to apply the L'Hospital rule. What it means that I have to do the differentiation of numerator and denominator independently. They are both independent. In the upper part, in the numerator, it will be 2x. Now come to the denominator part. In the denominator part, when we differentiate the square root of x square plus 9, I will be having 1 over twice under root x square plus 9. The first part is on differentiating the square root, and then I have to differentiate the part which is inside the square root, which is x square plus 9, which will ultimately gives me 2x, because plus 9 is equals to 0. Now both the 2 will get cancelled out. Here the x will get cancelled out. Okay. Now here it is like a limit x tends to 4, and this will go on the upper side twice under root x square plus 9. Now on applying the limits, it will be twice under root 4 square plus 9, which is 16 plus 9, which is 25, which is 5, and I will be having 2 times 5 is equals to 10 as the required answer. Okay, I think things are very much clear to you. There is no need to worry about the. Start with a question. These are some more questions we can do for the limits, and there are many more questions for the limits. We have to do many more questions, but just go with the starting first. This is x square minus 4, and this is in the denominator under root 3x minus 2 minus under root x plus 2. Okay. Now here directly, now I am applying the L'Hospital rule. I am not using any of the other methods. Okay. Now here this is a limit x tends to 2. Now here this is 2x. In the denominator you will be having 1 over 2 under root 3x minus 2 times 3 minus 1 over 2 under root x plus 2 times 1, which is of no use particularly. Okay. Now what else we can do here is there any suitable reason that we can apply the limits? Okay. We can try it on applying the limits. On applying the limits, I will be having 2 times 2. In the denominator, this is 3 over 2 under root 3 times 2 minus 2 minus 1 over 2 under root 2 plus 2. Okay. This is 2 times 2, which is equals to 4. Now here 3 over 2 times 6 minus 2 is 4. 6 minus 2 is 4, and the square root of 4 is 2. Now here this is minus 1 over 2, 2 plus 2 is 4, and square root of 4 is 2. Okay. Now I will be having 4 over 3 by 4 minus 1 by 4. Okay. On solving this, I'm going to the upper side. On solving this, I will be having 4 over 3 minus 1 over 4. This will give me 16, 4, 4, 16, and this is 2 here. This will be giving 8 as a requirements. Okay? And this way you can do it. Otherwise, if you have gone without using the L'Hospital rule, then in this particular case, you have to go with the method of rationalizing the denominator. What you have to do, if you are going with the not with the L'Hospital rule, then this is the method. Here you have to write out 3x minus 2 plus under root x plus 2, and here this is under root 3x minus 2 plus under root x plus 2, and it is very lengthy. Okay, and you have to use a lot of formulas here, but here in this particular case you don't have to use any of the formulas, and you can simply do the things in a very short method. This is the beauty, again the word is beauty, of what we call as L'Hospital rule. Okay. Now let's start with another topic, another question. This is the question of 2x minus 3, and this is over under root, and times under root x minus 1 over 2x square plus x minus 3. Okay. Now here this is the numerator part, and in this numerator part you are having two functions. One is 2x minus 3, another one is under root x minus 1. And if we are seeing here, if we apply 1 as the limit here in the denominator part, I will be having 2 plus 1 minus 3, which is equals to 0. It simply means that we can apply L'Hospital rules here. We can do it by other methods also. We can use the method of what we call the first here in the middle term split, and some more things we can do here. But here in this particular case, if we are having the denominator equals to 0, then we have to apply the L'Hospital rule. Here in the numerator part, we have to differentiate these part, and here this is fx and here this is gx. We know that for differentiating it, I can write it as limit x tends to 1. I have to keep under root x minus 1 as it is, and I have to differentiate 2x minus 3, and on differentiating 2x minus 3 I will be having 2, and then there comes the sign of positive. In the first bracket I will be having 2x minus 3, and in the second bracket I have to differentiate square root of x minus 1, which will be like this 1 over 2 root x. Okay, in the denominator part this is 4x plus 1. Okay, now if I try to apply the limit x tends to 1 in the denominator, I will be having 5, and the 5 is not equals to 0. What it means here is that there is no need to apply the L'Hospital rule again. You can simply apply the limits, and on applying the limits I will be having in the denominator this is 5. 4 times 1 is 2, 4 plus 1 is 5. Now here in the numerator this is 1 under root 1 minus 1, which is equals to 0. Here if I put 1 under root 1 minus 1, which is equals to 0, this part has gone to 0, plus 2x minus 3, this is 2 under 2, minus 3 is 2 minus 3 gives you minus 1, and here in the denominator this is 2 root under root x, and if I put x as 1, I will be having 2 times root 1, which is equals to 2 times 1, and which is equals to 2, and here this is 2. What it means that I will be having minus 1 over 2 times f, and here this is minus 1 over 10. This is the required answer, and this is correct method to do the questions on limits. These are all the algebraic questions. Just go for another question. We are proceeding to another questions. Okay. In this question, you are given like this. This is limit x tends to 27. Okay, and this is x raised to power 1 over 3 plus 3 x raised to power 1 over 3 minus 3 over x minus 27. This is the question which we are doing. In this particular question, if you put 27 in x in the denominator, you will be having 0, because 27 minus 27 is yielding 0. What it means that you have to apply the L'Hospital rule in this particular case again. Okay. Now, if I apply the formula of differentiation in the numerator part as well as the denominator part, one thing I can do here is just to avoid the lengthy calculation, we can do here as x square. This is x plus a, and here this is x minus a. It will give me x square minus a square. Okay. Now here in this case I will be having x raised to power 1 over 3 4 square minus 3 square over x minus 27. Furthermore, it can be rewritten as, this is of no use, but if you want to write it, you can write it as limit x tends to 27 x raised to power 2 over 3 minus 9 over x minus 27. And this is our question. This is the question. Now we have to do it. We can, if we go with the any method, we will getting very much lengthy of this question. But simply what we can do here is we have to just apply the limits. This is 2 by 3 x raised to power how much? Minus 1 over 3. Okay, and in the denominator it is just simply 1. Here I can write it as 1 because differentiation of x will give you 1. Now here this is the limit x tends to 27. On applying the limits here, now here if I apply the limits, I will be having 2 over 3 in the denominator I will be having 27 power 1 over 3, and which will give me 2 over 3 times 3, and it will be equals to 2 over 9. 2 over 9 is the requirements. Okay. Now in the same way, I have to do another question. I have to do with another question. Now here in this question, in the second in the 8th question, basically this is the 8th question. In this 8th question, what I have to do is, this is x power n minus 2 power n over x minus 2. Okay. In this question, there is a formula is also there. The formula says if you are having like this limit x tends to a and x raised to power n minus e raised to power n over x minus a, this can be rewritten as n times a raised to power n minus 1. And here you are having a as 2. Here a is 2. Therefore it can be written as a standing to 2. It can be written as n 2 times n minus 1 is equals to 8. Okay. Okay. Now here this is 8. Now here how I can write it as, I can put it as n is equals to 3. Okay. No. How it can be put here as 10. Actually this is, the question here is, this is not 8 because it won't make any sense. Here the question is 80. The number here is 80. Now we have to write it as 80, not 8. Okay. Now here this is 8. Now how can you do it? You can take the factors of 80. You will be having 2 raised to power 4 times 5. 2 raised to power 4 times 5. What it means? It means that here if you write it as n 2 raised to power n minus 1, then this part will be equals to this, and this is equals to this. What it simply means is n is equals to 5. But here for this, you have to remember this formula for n e times a raised to power n minus 1, or it will be given in your paper. But if you go with the method of L'Hospital rule, if you go with the method of L'Hospital rule, what you can write it here as, you can do here like this. This is limit x tends to 2, and here you will be having n x raised to power n minus 1 on differentiating x raised to power n, and minus 2 power n is a constant number. It will give you 0. In the denominator you will be having 1, and is equals to 80. Now on applying limits, because you have to apply the limit, because now denominator is not going to be 0 when you apply the limit. Now here you will be having n times 2 raised to power n minus 1 is equals to 80. Now see how much simple it has gone. Here you have to use the method, you have to use all the things. Now here you don't have to use things, and here you have to simply get up to the point where n is equals to 5. Okay? Just we have to start with the next question. Wait. Now see here, this is our question. Limit x is tending to under root 10, under root 7 minus 2x minus bracket root 5 minus under root 2 bracket close over x square minus 10. This is the required question. You have to define, you have to use the L'Hospital rule in this particular case, and let's do it. The one thing I am seeing here is that if I put under root 10 in the denominator, I will be having under root 10 square minus 10, which will yield to 0. It means that you have to differentiate it first, that is, you have to use the L'Hospital rule in this particular case. Now here the things goes like this. Limit x tends to under root 10. You have to differentiate this part. I will be having 1 over twice under root 7 minus 2x, and in the denominator minus 2. Another thing is this whole thing will goes to 0. There is no need to do the remaining part. You can write it 0 or simply just don't write it. Now here this is 2x. Okay, now this 2 will cancel out this 2. You will be left with limit x tends to under root 10. This is minus 1 over under root 7 minus 2x, and here this is 2x. Okay, now you are seeing that there is no need to apply the L'Hospital rule again, because if you put the limit x is equals to under root 10, then you are not getting the denominator equals to 0. Therefore, you can simply apply the L'Hospital rule here in this case the L'Hospital rule is already been used. Now here you have to apply the limits, and on applying the limits you will be having minus 1 over 2 times under root 10, and this is under root 7 minus 2 root 10. This is the required answer. But you can furthermore simplify this. How you will simplify the things? Now you are having 7 minus 2 root 10. It can be rewritten as under root 5 square plus under root 2 square and minus 2 root 5 and root 10, root 2. You can apply this thing. Okay? You can apply this thing. Okay? Because if you square under root 5, it will be 5. Squaring on under root 2, you will be having 2, and 5 plus 2 is 7. And here if you multiply these both the numbers root 5 and root 2, you will be having under root 10, you will be having the thing as 7 minus 2 root 10. But what is this? Actually this is under root 5 minus under root 2 whole square. Here you are simply applying the formula for a minus b whole square, which states so a square plus b square minus 2ab. But here again one thing is there. Here this is the square root. This is minus 7 minus 2 root 10, and if I put the sign of under root, now I will be having like this 2 will cancel out this, you will be left with under root 5 minus under root 2. Okay? Now here this is minus 1, this is 2 root 10, and here this is under root 5 minus under root 2. Now what else we can do here? We can rationalize the denominator in order to make the denominator square root free. Now in order to make the denominator free from the square roots. Now everything has been done by you. I am just coming on the last part. Now here what it says. What it says, if you could do the things like rationalizing the denominator here, this is minus 1 over 2 root 10 and times under root 5 minus under root 2, multiply by the numerator, it will comes to be under root 5 plus under root 2. Here this is under root 5 plus under root 2. Now here this will give you minus under root 5 plus under root 2, and the denominator 2 root 10, and here you have to apply the formula for a minus b and a plus b, which will give you a square minus b square. If I apply the formula here in this straight, if I apply the formula here in this part, I will be having under root 5 square minus under root 2 square. You will be having 5 minus 2 as 3. 3 is the required answer. Okay, now what is left? Left is minus under root 5 plus under root 2 over 6 root 10, and if you could multiply both the sides, both numerator and denominator by root 10, I will be having, I am just writing it here, minus under root 5 plus under root 2 times under root 10 over 6, 10 just 60. 60 is the required part of the denominator. This is the required answer for this particular question. Okay? With the help of this method, L'Hospital rule, you have seen, you have saw that how you can do the solutions of the limits of any number, any algebraic quantity. In this way, you can do the solution of, or you can say you can find the limits for any algebraic questions. In the next class, we will be doing the questions on L'Hospital rules or on the topic of trigonometric activities. Okay, just wait. I am writing a question for you for the homework purpose. This is the question number 10, and this is for you to do in the homework part. And just do this question and let me know the answer of this question. Okay, do the question and write down the answer in the comment box. And please like, share and subscribe my videos. Okay, bye.